Okay, so let's start with the first system of equations. To write the augmented matrix, all you have to do is take the coefficient of every variable in the system of equations. Okay, so now we need to row reduce the matrix to RREF. We have a leading 1 in row 1, column 1 of the matrix already, so the next two steps are going to be to make zeros for row 2, column 1, and row 3, column 1. So to do this, we need to multiply row 1 by -1 and then add to row 2. Now we are going to get a 0 in the third row, first column. To do this, we need to multiply row 1 by -k and then add this to row 3. So the next step is to create a leading 1 in column 2. The leading 1s need to be below and to the right of the previous leading 1. So we're going to put it in the row 2, column 2 position. So to do this, we need to multiply row 2 by 1 over k minus 1. That way we'll get a 1 in that position. I also want to explain how I got -1 in row 2, column 3. So you can see my work below, I have an arrow pointing toward it. So if you take out a -1 in 1 minus k, you can cross out k minus 1 in the numerator and denominator, and that'll give you -1. Now that we have a leading 1 in column 2, to satisfy RREF, we need the other entries in column 2 to be zeros. So we're going to make row 1, column 2 a 0 first. We're going to do this by multiplying row 2 by -1 and then adding this to row 1. Now we're going to create a 0 in row 3, column 2. And to do this, we are going to multiply row 2 by k minus 1 and add this value to row 3. Now that we're done row reducing the matrix, we have to determine when the system will have no solution. It'll have no solution when row 3 has an equation of 0 equals n being any real number. So I solved 2 minus k squared is equal to 0, and you get k equals 1 and k equals -2. When you substitute k equals 1 into the elements with k, you get 0 on the left-hand side and -3 on the right-hand side. So this satisfies the system having no solution when k equals 1. The system will have a unique solution when x3, which is the variable for the third column of the matrix, is defined. So x3 will be defined when k is not equal to 1 or -2. For the system to have infinitely many solutions, row 3 would have an equation of 0 equals 0. Earlier I solved 2 minus k squared equals 0 when k is equal to 1 and -2. Now if you substitute -2 into both elements that have k, you get 0 on both sides. So the first step again is to write the augmented matrix, and you can do this by taking the coefficient of each variable in the system of equations. So because we already have a leading 1 in column 1, we have to make the other entries in that column zeros. So to do so, we are going to multiply row 1 by -3 and add to row 2, and then multiply row 1 by -4 and add to row 3. Okay, so now we need a leading 1 in column 2. Once again, leading 1s need to be below and to the right of the previous leading 1. So this is going to be row 2, column 2. To get this to be a leading 1, we need to multiply row 2 by -1/7. So the next two steps of row reducing this matrix to satisfy RREF are to get zeros in column 2 other than the leading 1. I'm going to go ahead and do both of these steps in one just to make it a little faster and because neither equation affects the other. So to get a 0 in row 3, column 2, multiply row 2 by 7 and add this to row 3. To get a 0 in row 1, column 2, multiply row 2 by negative 2 and add this to row 1. Now that we're done row reducing the matrix, we have to determine when the system will have no solution. This will be true when row 3 has an equation of 0 equals n being any real number. Earlier I solved k squared minus 16 equals 0 when k is equal to plus and minus 4. So when k is equal to negative 4, you have 0 on the left side and negative 8 on the right side. So this satisfies the system having no solution. For the system to have a unique solution, x3 has to be defined. So this means k squared minus 16 has to be any number other than 0, and k minus 4 has to be any number other than 0. So the system will have a unique solution if k does not equal plus or minus 4. The system will have infinitely many solutions when row 3 has an equation of 0 equals 0. So k squared minus 16 equals 0 when k is equal to plus or minus 4, and k minus 4 equals 0 when k is equal to positive 4. So the system has infinitely many solutions if k is equal to positive 4.